I really forgot how pretty this campus is. It takes me back. I'm here because about 20 years ago I got my undergrad here in computer science, and now I'm getting my PhD in this thing called software engineering. And PhDs in software engineering are few and far between right now. And so that's what we're starting here at Arizona. We're starting a software PhD program. I'm going through it. I'm learning. I used to be here at University of Guelph, got my computer science degree 20 years ago, did a bunch of stuff in between. Now I need to write about it. And how do I teach some of this stuff? Well, I got to go through the academic process, and that's what's happening with me here. And I'm perfectly happy to do it, and it's exciting, and I'm learning a ton. And hopefully I can teach a little bit as well while I do this sort of stuff. But here's the issue. I've been talking about optimizations, research, 3D, whatever. And here's how it all comes together, for me anyways. Sustainability is a huge, huge issue for me. What does that mean? Well, if you look outside, it's pretty, and I'd like to keep it that way. And that's kind of what we're going after. At the end of the day, computer science has had the benefit of the doubt, because every time we've coded something, it was in the way of reducing how many pages we print. Emails had saved us from tons of communications and letters. All of that was very easy to quantify as a better environmental impact. But today, that code and our children don't remember that transition. What they do know is we run NFTs for 5 years with no real benefits. All right, it's a ledger. Bitcoins that are unsustainable in terms of computer hardware. Gen AI solving problems that we don't want solved, right? So we use computers to do a lot of things. That doesn't mean those computers cannot get more efficient as we do things. And that's coding and sustainable practice. And that's what I talk about here today. So as we think about coding as sustainable practice, what I think about is the idea that like a web service understands its own power consumption. If I create a solar panel and a battery and an Arduino, Raspberry Pi with some kernel management around that power, I can understand that the battery is full, the solar panel is creating energy, and I can serve up to 100% of a power consumption model. But when the sun goes down and the power goes out and you're on battery, you have to reduce the value or how much you serve up. If you're going to have 100 customers or 1,000 customers, great. Maybe you can still serve up a full page. But if you're serving up 10,000 customers, maybe you got to step down the type of value you're providing with the page. If you have 1 million customers, maybe only a text-based web page will serve up with the power that the battery can provide and the system consumes. But maybe there's more efficient ways to serve up that web page. Maybe you only get 20 customers an hour. Maybe it's cloudier longer than you thought. All of these problems mean that this page and how it serves up cannot be timed. It has to be aware of the power it consumes. And that's my research, and that's what I'm going to start more and more. I'm going to talk about the power of the sun as a way to constrain the system. The power of the sun creates so much energy. That energy has to be stored, and you have to calculate how much energy you have and how much you're using. This will allow you to understand when you're going to run out and how you have to serve up that energy. That's the research I'm doing nowadays. I'm super excited because I think the ramifications of sustainable coding practices have effects for generations to come. And I hope university students understand that, this generation, and do a better job than we do.